In this video, we're going to be discussing trees and data structures. So we can see that we have this tree on the left, root M, children DT, and then subtree D has children AF, and subtree T has child Z. So we can calculate the number of nodes by just counting how many circles we have. So that's 6. To calculate the height, you look at the longest path and you examine the edges. So we can see that we have a path from M to D to A, and we have 2 edges. Now we want to find the depth of F. In order to do this, we can look at the path that we take in order to get to F. So we have M to D to F, and our depth is the number of edges from the root. Number of edges from the root. And this is the longest path edges. So from M to D to F, we can see that this is going to be 2. From 2 edges. Now we can calculate the width of this tree. The width is defined as the length of the longest path in nodes. So we can see that we have M to D to A as a path we can take. That's going to be 3 nodes. And we see that M to T to Z is also going to be 3 nodes. So our longest is going to be 3. We can identify our root as being M because our root is the node that has no parent and is also the very first node, the very topmost one. Let's find the number of leaves. A leaf is something that has no children, and it's at the very bottom of the tree. So we can see that's going to be A, F, and Z. Now we can find the number of parents. The number of parents is going to be M, D, and T included in parents. That's going to be 3. Now to be a parent, you have to have children. Let's find the number of only children. So we can see that Z is the only child of T. And we know that an only child has no siblings. So that means on that level of the tree, there is no other nodes. So the only node that met that condition was Z. And that is just 1 node. Now, how about the number of nodes at level 2? So when you split it into levels, you start at 0, 1, and 2. So we can see at level 2 there are 3. We can see at level 2 there's A, F, and Z. So that's just going to be 3. Now let's do traversals. So when we do traversals, if we do pre-order, we know pre-order is when you examine root, then you look left, and then you look right. What this means is you look at the root first, you process the root. After you process the root, then you process the left subtree. And then after you process the left subtree, then you process the right subtree. So, doing this, we have here, we start off with M as our root, then we go to D, and then we go AF, because these are, we can actually map this out. So we start off with M, then we go to D, then we go to A, because we finished this left subtree, and then after we go to A, we go to F, And then after we go to F, we go to T, then we go to Z. So then this is going to be M, D, A, F, T, Z. Now, for our next one, we have in order. And in order means that you go left, then you go to the root, then you go right. And what this means is that you visit the left subtree, then you process the root, then you visit the right subtree. So let's do this. In order, we're going to start off with the left. So on the left, we start off with A. Now from A, we go to our root. So that's going to be up to D. And then from D, we go to the right. So we go down to F. Now from F, we go to M because we have to go to the root. Now from M, we have to go right. So we're at T. And then from T, we have to go right again. Finish this. So we are at Z. So we can write for our in order A, D, A, F, D, Z, T, M. Now, finally, we have our post order, or second last. We have our post order. So post order is when you do left, right, root. Now, let's demonstrate this. So for post order, we're going to start off with visiting the left subtree, then we visit the right subtree, and then we process the root. So let's start off with left. So that's going to be A again. And then after A, we have F, and we have D. We start off with A. You start off with A, then you go to F, then you go to D, then you go to Z, then you go to T, and then you go to M. So this is going to be M, D, T, A, F, Z. Now, what we can do now is we can calculate the balance and also the heights. So let's do the heights. Our tree kind of got messy, but it's okay. We can find the heights of each node. So when you do the heights, you examine the tree from bottom up. So let's first do the leaves, because the leaves are always going to have the same height. So for the leaves, we can do the height is equal to 1 plus max, and that's going to be -1, -1 is equal to 0. So the height is going to equal to 0 for all these three nodes. Now, after this, we can move up. Let's do node D. So for node D, what you do is you would look at the left node, and then you look at the right node. So the left node had a height of 0, and the right node had a height of 0. A had a height of 0, and F had a height of 0. So then you have H is equal to 1 plus max 0, 0, and that's equal to 1. Now, again, let's do this for T. So node T, it had on the left side, it is null because there's no child. T has one child, and that is Z, and Z is an only child. So that means on the left side, there is nothing. And the height of a null node is going to be -1. So then you write the height as height is equal to 1 plus max -1, 0, and that's going to equal to 1. Our levels, I'll move that over there. And now let's do M. So M, we can look on the left, D has a height of 1, and on the right, T has a height of 1. So if we calculate the height, it's going to be 1 plus max 1, 1 is equal to 2. Okay, now we can find our balance factors. Okay, so let's start off with the leaves. Again, you work from bottom up. So these leaves are all going to have the same balance. So it's going to be -1 minus -1 is equal to 0, and this is going to be the balance for A, for F, and also for Z. So now let's do node D. So here, our balance is going to equal to 0 minus 0, which is 0. Now for node T, we have our balance is going to equal to -1 minus 0 is equal to -1. Now for our node M parent, our balance is going to equal to 1 minus 1, which is equal to 0. And this is our first tree completed. So now